Hello students, today I am here to teach you chapter 8 in your textbook that's called Areas of Plane Figures Between Parallel Lines. So this is a geometry lesson and you need to know 6 theorems in this lesson. And before we start the 6 theorems, we'll look at basic knowledge in parallelograms and triangles. Now what is a parallelogram? You know already parallelogram is a four-sided figure and opposite sides are parallel. So I'll take this parallelogram ABCD. How can we find out the area of this parallelogram? Area. When you take ABCD parallelogram, I'll draw this perpendicular line to this one. What you call the perpendicular line? Altitude. Or we can take as H as the perpendicular line. And also I'm taking another perpendicular line to this BC line. I'll label that as K. So if you want to find out the area of the parallelogram, when you take this one, area A is equal to, what's the formula? Base into perpendicular height, altitude. So here I can take, what's the base here? If I take this side as the base, AB, I'll put A for that. Base A times the perpendicular height, H. So what is A? A is the base and H is the altitude or perpendicular height to this base. Now if I want the same area from this side, if I take this one as the base, how can I write down the area? I can take, if this base BC as B, what's the area of the parallelogram? Base is B here times, what's the perpendicular height to that base? This is K. So this is also altitude and this is the base. But we know this is the same parallelogram. The area is the same. So we can equate these two. So I can write, by looking at this, A times H should be equal to B times K. So this is important in parallelograms. If you select any base, you have to select the corresponding perpendicular height. So remember this one. One base into one perpendicular height is same as the any other base into perpendicular height. Now we'll look at some examples to find out parallelogram. This is a parallelogram because opposite sides are parallel. What is this one given? This is the base. Base length is 12 and the perpendicular height is 9 given. So how can we find out the area? Area is equal to perpendicular, the base is 12, perpendicular height or altitude is 9. So what's the answer? 9 times 2, 18, 1 remaining, 9 times 1, 9 plus 1, 10. So the answer is square centimeters, 108 square centimeters for this area of the parallelogram. Now look at this one. Now the base is given this side, 9 centimeters and the perpendicular height is 11 centimeters. How can we find out the area? Area is equal to, base is 9, perpendicular height or altitude of this one is 11. So what's the area? 9 times 11 is 99 square centimeters. Now try this one. In this situation, what's the difference? We are asked to find out this length B. Nothing given, only given the sides, the other base and a perpendicular height and another perpendicular height given. So what's the theory we can use? We know if you take any side as the base, the area is the same. So we can equate. So if I take this side as base, what's the area of this parallelogram? A is equal to 9 times 8. And also we know that if you take B as the base, what's the area? B times perpendicular height or altitude is 12. Now we get an equation, we can find B. 9 times 8 is 72 is equal to 12B. So what's the B value? Divide both sides by 12, you get 6. What's the unit? All these units in centimeters, take centimeters as the length of B. Now we need to look at what's the area of a triangle. Now we'll take a triangle. You can take any triangle, acute angle or right angle triangle or even obtuse angle triangle. What's the area? For any triangle, if we know the altitude or the perpendicular height to one base, if this is A and this is H, how can we find out the area? Area is half times base times the altitude. Altitude or perpendicular height. This is the base. So you need to know the area formula for triangle. Now we'll take any triangle ABC and the perpendicular line to this one, I'll write K, AK. And the perpendicular line to this one, I'll draw KL, BL. And the perpendicular line to this one, I'll draw M, CM. What's the property there when you draw perpendicular lines or altitudes from all these points? All altitudes passing through the same point. That's another property. Now we'll see how can we find out the area of this triangle. So what's the area? If area is A, if I take BC as the base, what's the perpendicular height or altitude? That's AK. So I can write half times BC times AK. Or I can write, if I take this as the base, what's the formula? AC into BL. Or if I take this as the base, what's the formula? A equals half times, this is the base now, AB times, what's the altitude or perpendicular height? CM. So that's how we find out the area of a triangle. Now we'll see how to calculate the area of these triangles. The base is given and the perpendicular heights are given. So what's the formula? Straight away you can use the formula. A is equal to half times base is 12 and the perpendicular height or altitude is 8. Now try to simplify and get the answer. 2 times 6, 6 times 8, 48. What's the unit? Square centimeters, because all these lengths are given in centimeters. This one. What's the base? Base length is 9. So how can we find out the area? Half times 9 times the perpendicular height is given as 11. So how can we simplify? We can't simplify denominator with numerator, so we can multiply. 9 times 11 is 99, divide by 2. What's the answer? 2 times 4, 8, 2 times 9, 18, 49 and a half, or you can write 49.5 square centimeters. This one, again, perpendicular height is given 7 centimeters and the base is given 16 centimeters. So how can we find out the area? Half times 16 times 7. Here we can simplify. 16 and 2 we can simplify as 8. 8 times 7, 56 square centimeters. Now, there are several diagrams and you are asked to find out the area of the following triangles and parallelograms. Now, we'll try to find out the area and first we'll find out the parallelogram. Area of parallelogram. What's the formula? This is the parallelogram. So here that means this length is parallel to this one. This one is parallel to this one. So we can say base is 12 and the perpendicular height is 7. So 12 times 7. What's the answer? 84 square centimeters. Now, what's the triangle there? I want to find out this area, this triangle. When you take the area of the triangle, you can use the same formula. Here, what's the formula we can use? Half times base times height. Base half times base is 12 and height is 7. When you simplify this, you get 42 square centimeters. Do you see a relationship between these two? 42 times 2, you get 84. Think about carefully. Area of a triangle and area of a parallelogram. Again, we'll look at this diagram. This is a parallelogram. What's the area of the parallelogram? So base is 16 and the perpendicular height is given 8. 16 times 8. That's the answer. 48 and plus 228 square centimeters. If I want the area of this one, how can I find this area? What's the base there? Base is this. But we can draw the perpendicular line any place, here or here. You get the same height. So area of triangle is base is half times base times the same perpendicular height. Then when you simplify, you get 64 square centimeters. Again we see double of 64 is 128. Now what about this one? You have given a parallelogram and I want to find out, I'll draw another line here. I want to find out the area of this triangle. So how can I find? What's the area of the parallelogram? Here, without writing this one, I'll draw this symbol. It's easy. Without the word parallelogram, area of parallelogram, I can write base is 11 times height is 8. So 11 times 8, I'm getting 88. And if I want this area of the triangle, again, area of here, I'll draw this symbol now. Area of the triangle is half times base is 11 and the perpendicular height is 8. When you simplify, you get 44 square centimeters. So in this case, when you get a triangle and a parallelogram with same base and in between pair of parallel lines, same parallel lines, we see a property. Always double as the triangle. Area of parallelogram is double as the triangle. So we are doing this one as a theorem later. Now we'll look at this diagram. What we can see. When we look at this diagram, we can see AB line parallel to QC. And also here AQ parallel to this one, PB, AD parallel to BC. We see this is a parallelogram. A, B, P, Q is a parallelogram. What else we can see? We see A, B, C, D also a parallelogram. And what's the important thing we see? Both parallelograms has same base. So I'll draw in another color. When you take this and this both, this is common base. And what else we can see? Both these triangles in between the two pair of parallel lines AB and CQ. So we can say when you look at this diagram, ABPQ and ABCD, both these parallelograms on the same base. What's the base there? AB. Same base and between pair of parallel lines AB and I can write like this, AB and CQ or QC. Two parallelograms on the same base in between pair of two parallel lines. Now we'll look at another diagram. What can you say about this diagram? You get two parallelograms. What can we say? Same base for both parallelograms. But these two parallelograms are not in between the same pair of parallel lines. This one is different. So what can we write about this diagram? We can say ABCD parallelogram and ABPQ parallelogram on the same base. AB. Same base AB, but these two are not in between. Not between pair of parallel lines. Not between same pair of, I'll write the word same pair of parallel lines. So here in this diagram, we can see these two parallelograms on the same base but not between same pair of parallel lines. Now look at this diagram. What can you see? There are two parallelograms. What are the parallelograms we can see? A, B, C, D is one parallelogram because opposite sides are parallel. And also, look at this side. This one is also a parallelogram. AB, PQ is another parallelogram. When you look at those two parallelograms, we can see this length is common. I'll draw with another color. AB is the common base. So we can write down both these parallelograms on same base AB, and also when you look at these two parallel lines, both are in between those two parallel lines AB and CQ. I can write both between same pair of parallel lines AB and QC. I can highlight these two. AB is common. Or I can write here big AB and CD and PQ here. Because then I can see AB is common to both these parallelograms. When you look at this big one and the smaller one, what can you say? Smaller one is not in between the same pair of parallel lines. But if you take the small parallelograms, this one and this one, A, B, X, Y, I'll write like this, A, B, X, Y and A, B, K, L. Same as before. We can say both on the same base AB and between same pair of parallel lines AB and LX now. So when you get different diagrams, you should be able to understand how we can figure out the same base and check how can we check whether the two parallelograms are in the same pair of parallel lines. Now we'll look at the review exercise in your textbook, and using the basic knowledge you had now, how to find out the answers. In this question, you have given several triangles and several quadrilaterals. These two parallelogram and this is a rectangle. And you are asked to figure out what's the base, corresponding altitude and the area as a product of length. Okay, so we'll start the first one. Triangle ABD. When you take ABD, what's the base? You can either take this as the base or AD as the base. I'll take BD as the base. If I take BD as the base, what's the perpendicular height or altitude? Then I have to take the other length, AD. Then what's the area? Area is half times base times altitude. Second one, STU. STU, you can take only one base. What's the base there? ST, because this is the altitude given. What's the altitude? UV. How can we find out the area? Half times ST times UV. The third diagram, triangle WXY. This one, this is an obtuse angle triangle. You have to take this as the base because this is the perpendicular height or altitude. So what's the base? WX. Altitude is YZ. And the area of this triangle is again half times base times altitude. Fifth one. Before that, fourth one. It's a rectangle. Again, you can take any side as base. If I take CD as the base, what's the perpendicular height or altitude? It becomes AD. Area of rectangle or triangle, base times height. You can just straight away multiply CD times AD. Fifth one, a parallelogram. Base is given HG. What's the perpendicular height or altitude? EI. I'll write HG as the base, then EI is the perpendicular height or altitude. When you multiply base and altitude, you get the area of the parallelogram. Last one. This side is given as the base because the perpendicular height here. JK is the base and the perpendicular height is MN. How can we find out the area? Base times altitude. JK times MN. Now we look at exercise 8.1 in your textbook. First question says, based on the information in the figure, name 4 parallelograms. Look at carefully and see what are the parallelograms. You need to find out 4 parallelograms. If you take these two lines, parallel lines, what's the first one we can see? I can see this is a parallelogram. PQLM is a parallelogram. What else? I see the big one also, this line is parallel to this one. I can see PR MK is another parallelogram. What else? What about this one? This one? This is also a parallelogram. QRON is also a parallelogram there. And what about this small one? Small one is also a parallelogram. QRML is also another parallelogram. So we got 4 parallelograms in this diagram. And then it says name the 2 parallelograms with the same base QR. QR. Can you see starting from QR? So what are the 2 parallelograms with the same base QR? These 2. I can write for part 2. What are the 2 parallelograms? QRON and QRML. These are the 2 parallelograms between the same parallel lines AB and CD. This is CD and this is AB and the same base QR. Now look at the question number 2. Write down all the triangles with the same base OP. So they need this base, same base OP that lie between the pair of parallel straight lines AQ and CP. What are the triangles? Can you see? This is one triangle and this is another one. What's the third one? This is the third one. All these triangles with this same OP base. So I can write down all these triangles. OPQ is one triangle. OPM is the second one and OPL is the third triangle. Now look at the question number 3. In the given figure, the perpendicular distance between the pair of parallel straight lines AB and CD is denoted by h. So this is the perpendicular height or altitude in between these 2 parallel lines. And lengths of the parallelograms by A. It's given AB is A. Base lengths, not AB. Base lengths of the parallelograms by A. So you have to take this parallelogram. What's that parallelogram? MNUT. And what's the other parallelogram? PQRS, this parallelogram. PQSR, not PQRS. PQRS parallelogram. And you are asked to find out the areas. Write down the areas of the parallelogram. We know area of a parallelogram is base times height. So what's the PQRS area? Area of PQRS parallelogram is, base is B, and what's the perpendicular height? Perpendicular height is h. When you take the other parallelogram MNUT, how can we find out the area? Now the base is A. A times the same perpendicular height because both parallelograms in the same pair of parallel lines. A times H. So that's how we write down the area. Fourth one, the rectangle KLMN and the parallelogram PQMN in the given figure lie between the pair of parallel straight lines AB and CD. AB and CD. NM is 10. This length is given 10 centimeters and LM, what is LM? Is the perpendicular height is given 8 centimeters. First part it says find the area of the rectangle KLMN. This rectangle. How can we find out the area? Base length into height. We can straight away write down base is 10 and the perpendicular height is 8. 10 times 8, 80 square centimeters. Second part, find the area of the parallelogram PQMN. PQMN, this area. I'll take another color. Now you are asked to find out this area. What's the area? You get the same base and same perpendicular height. 10 times 8, 80 square centimeters. And the third part it says what is the relationship between the area of rectangle and area of the parallelogram. What can you see? You get the same area. I can write area of KLMN is same as area of PQMN. This is a rectangle. KLMN is a rectangle and this is a parallelogram. Now we look at theorem 1 in your textbook. Parallelograms on the same base and between the same pair of parallel lines are equal in area. Now we'll try to prove this. What's given there? In this diagram, it's given a P line is parallel to DE line. And also we can see ABCD parallelogram, this parallelogram, and the other parallelogram ABEF. On same base. AB and between two parallel lines ABN or AP and DE. DE. That's given in the diagram. Now what we need to prove? We need to prove the area of ABCD is same as area of ABEF. Now we'll start to prove this. We'll look at ADF triangle and BCE triangle. What can you say about these two triangles? These two lines are parallel. if this angle is x, what can you say about this angle? This is also x because corresponding angles are equal. I can write ADF angle is same as BCE angle, corresponding angles. What else I can write? This angle, if I take this as y, what is this one? This is also y. AFD, this angle is equal to BEC angle. It's also corresponding angles. And this one, this length, what can you say about AD and this length? Both are equal because this is a parallelogram. Opposite sides are equal. AD is equal to BC. Opposite sides of a parallelogram. So both are equal. So what can you say about these two triangles? These two triangles are congruent. ADF triangle is congruent to BEC triangle. So what's the situation? Angle, angle, side. Angle, angle, side. When these two are congruent, what can you say about the area of the triangles? I can say this area is same as this area is same as this area. I can write ADF triangle area is equal to BEC triangle because these two are congruent. Now I want to add this area to both sides. What happens when I add this area? That's a pentagon. I'm adding ABCF. It's not a pentagon, it's a quadrilateral and it's a trapezium. ABCF is a trapezium. I can add to both sides. When I add these two to both sides, what happens? What you get when you add this one and this one? I get ABCD parallelogram. These two becomes ABCD parallelogram. What about the other side? We'll check BEC triangle. This and this part, you get ABEF parallelogram. So what can you say? Both these are equal in area. So that's how we can find out the area between same pair of parallel lines and on the same base, both are equal. Now we look at theorem number 2. Here theorem number 2 says parallelograms on equal bases and between the same pair of parallel lines are equal in area. What's the difference between the previous one and this one? Earlier, both parallelograms on the same base. Here, these are not on the same base, but bases are equal. Bases are equal here. Then how can we find out the areas of these two parallelograms? We'll try to prove. What we know? We know AB length is equal to PQ. And both ABCD parallelogram and PQRS parallelogram, both between same pair of parallel lines AQ and DR. I want to do a construction here. Construction. I want to draw the perpendicular height. To this two parallel line as H. I'll take as H. So the construction is draw a perpendicular line to parallel lines A, Q and DR. And I'm taking as H. Now we'll take the proof. We need to prove that ABCD parallelogram area is same as PQRS. We'll take ABCD parallelogram. What's the area? Area is base. If you take base as AB, then what is the perpendicular height? Perpendicular height is H here. And how can we find out the area of PQRS parallelogram? The base is PQ now. PQ and you get the same height, perpendicular height. Now we know that AB is equal to PQ. That's given. As AB is equal to PQ, we can say these two areas also equal. ABCD area is equal to PQRS parallelogram. So in this case, theorem 2, two parallelograms are in between same pair of parallel lines, but not the same base. The bases are equal, but areas are equal as well. Now we'll look at theorem number 3. Theorem number 3 says triangles on the same base and between the same pair of parallel lines are equal in area. Earlier we discussed about parallelograms. Now about triangles. So what is given there? Given there AB P triangle and ABQ triangle, both on same base AB and lies between AB line and PQ line. That's given. you need to prove ABP area is equal to ABQ area. And we'll see how we can find out the area, but we need to do a construction. There, I'll draw perpendicular height. And take H. Draw perpendicular line. Now we'll start to prove this. We know what's the area of ABP triangle? Half times base. Base is AB. And what's the perpendicular height? Perpendicular height is H. What's the area of ABQ triangle? Half times base is same, AB, and perpendicular height is H again. So we can see both sides are equal according to 1 and 2. Both are equal. Therefore, ABP area is equal to ABQ area. So when you get two triangles on the same base, in between same pair of parallel lines, the areas are equal. Now we'll look at theorem 4. It says triangles with equal bases and between the same pair of parallel lines are equal in area. What's the difference between the previous one? Previous one, both triangles on the same bases. Here, different bases but equal in size. How we can prove this? We'll take the data, the things that we know. We know AB length is equal to PQ length. And also both triangles lies between pair of parallel lines AQ and CR. And we need to check the area. So that's what we need to prove. ABC area is equal to PQR area. And here also I need to draw a construction. I need to draw the perpendicular height. I'll draw the perpendicular height to these parallel lines as H. Perpendicular. Draw perpendicular height H. Now I need to find out the areas of the two triangles. What's the area of ABC triangle? Area is half times base is AB and the perpendicular height is H. What's the area of PQR? PQR is half times PQ length into H. When you look at these two, what can you say? As AB and PQ equal, you get right hand side as the same. So as AB is equal to PQ, I can see 1 and 2 both are equal. That means ABC triangle area is equal to PQR triangle. So these two areas are equal. What's the difference between the previous one? Here, same pair of same pair of parallel lines but different bases, but the bases are equal. Now we'll look at Theorem 5. Theorem 5 says, if a triangle and a parallelogram lie on the same base and between the same pair of parallel lines, then the area of the triangle is exactly half of the parallelogram. So when you look at the diagram, this is the triangle. I'll use a different color. This is the triangle. And I'll draw with another color. This is the parallelogram there. So you have to find out the areas and see whether the area of the triangle is half of the area of the parallelogram. So what's given there? Data given ABCD parallelogram and ABP triangle, both on AB base and between same pair of parallel lines AB and CD. We need to prove ABP triangle area is half of ABCD parallelogram. Now we need to draw a line there, a construction. I want to draw the perpendicular height here as H. So what's the construction I'm going to do? Draw a perpendicular line with length H. Now we'll try to prove that. What can we say about the ABP triangle? ABP triangle. What's the area? AB is the base. So half times AB times the perpendicular height H. What can I say about the area of the parallelogram? ABCD. Area of the parallelogram is base times height. What's the base? AB and H. When you look at 1 and 2, what can you say about these two? Same thing, but this is half of that. So I can plug this part here and write down ABP triangle area is equal to half of, instead of this I can plug this area, half of ABCD parallelogram. So that's the theorem number 5. So if you want any triangle area and the parallelogram area with same base and in between same pair of parallel lines, we see that the area of the triangle is half of the area of the parallelogram. Now we'll look at theorem number 6. This is not in your textbook, but this is also important. Converse theorem. What is converse theorem says? In converse theorem, when the two areas of the triangles are equal, and also if we know these two, and also if we know these triangles in between pair of lines AB and PC, if these two areas are equal, we can say that the two lines are parallel. That's the converse theorem. In the converse theorem, what's known? We know that ABP area is equal to ABC area. And also these two triangles in between two lines AB and PC, and both are on the same base. Both are on the same base. AB. That's given. And I need to do a construction now. Construction is drawing the perpendicular height. I'll draw this perpendicular height as PL, and this perpendicular height to this triangle is CM. What's the construction? PL is the perpendicular height to ABP triangle, and I drew CM is the perpendicular height to ABC triangle. Now we'll try to prove this. We know the areas are equal. We'll take the area of ABP triangle is equal to, if we take this as the base, half times base times PL. PL is the perpendicular height to that triangle. That's first one. Then we know AB, when we take ABC triangle, what's the area of that one? Half times AB times perpendicular height is CM. But we know from the given data, these two areas are equal. So because 1 and 2 equal, we can say half times AB times PL is equal to half times AB times CM. What can we see now? Half get cancelled out, AB get cancelled out. We can see PL is same as CM. These two perpendicular heights are equal. If the two perpendicular heights are equal, what can we say about the two lines? These two should be parallel. Because these are equal, we can say AB length should be parallel to PC length. So that's the converse theorem. Now we'll try to revise all theorems that we covered. What's the first theorem say? It's about parallelogram. Two parallelograms on same base and between same parallel lines what can we say about the areas? When two parallelograms with same base and same parallel lines both are equal. Areas are equal. Then the second theorem, that's also about parallelograms, but what's the difference? Not on the same base, different bases. Different bases, areas are equal, but these two bases should be equal. We can say equal bases and between same parallel lines areas are equal. And the third one, we discussed about a triangle. When we have, I'll go to the first one again. Here, I need to draw this diagram because same base. Here, when you take a triangle with same base and between two pair of parallel lines, the areas are equal. Here, in third theorem, same base on same base and between same parallel lines areas are equal. So that's about triangle. Fourth one, that's also about triangles but not the same base. Equal bases. Equal bases with the same. In the fourth one it says equal bases but in between same pair of parallel lines. The areas are equal. Equal bases and also between same parallel lines areas are equal. And the last one and the fifth one we said, when you look at a triangle and a parallelogram on the same base and between same parallel line, the area of the triangle is equal to half of the area of the parallelogram. That's the fifth one. Sixth theorem is the converse theorem. It says in the sixth theorem, if two areas are equal and the two triangles in between two lines with same base, then we can say the two lines are parallel. Here same base, same area, then two lines are parallel. So in this lesson we discussed about 6 theorems. Now we'll try to apply these 6 theorems in exercises. The area of the parallelogram ABEF in the figure is 80 square centimeters, while AB is 8 centimeters. So this is given 8 centimeters as AB, and the area of this parallelogram, the area of this parallelogram is given 80 square centimeters. In first part, name the parallelograms in the figure that lie on the same base and between the same pair of parallel lines. What are the parallelograms? We can say ABEF parallelogram and ABCD parallelogram. Both are on the same base AB, and in between the two pair of parallel lines AB and FC. And the next one, what is the area of the parallelogram ABCD? We know that the area of ABEF is 80 square centimeters. And according to the theorem, we know that if the two parallelograms on the same base and in between same pair of parallel lines, the areas are equal. So that means this area and this area both are equal. So we can write 80 is same as ABCD parallelogram. So 80 square centimeters. Because we know this is same as ABEF area. On same base, we can write down the reason, on same base and between same parallel lines. Again, what's the third part? Find the perpendicular distance between the parallel lines AB and FC. So if the perpendicular line is H, we know that area of the parallelogram is base times H. Base is 8. 8 times H is the area. Area is given as 80. So how can we find out H? H is 80 divided by 8. We can write 10 centimeters. So that's the perpendicular height in between two parallel lines. Example number 2. According to the information in the above figure, show that ABQD and ABCP are parallelograms. ABQD. We'll look at the diagram. ABQD. This one. What can you say? We know that AD is parallel to QB. And also we can see AB line parallel to DQ. Opposite sides are parallel. Opposite sides are parallel means this is a parallelogram. So therefore, ABQD is a parallelogram. Then ABCP. When you look at ABCP, ABCP is this one. Again, we can say AB is parallel to PC, this line, and AP parallel to BC. Again, opposite sides are parallel. That means this is a parallelogram. ABCP is a parallelogram. That's the first part. Then second part, it says, show that parallelograms ABQD and ABCP are the same area. We need to show that both are equal. What can you say about the two parallelograms? Both are on the same base AB. We can write ABQD and ABCP parallelograms both on same base AB and in between same pair of parallel lines, What are the parallel lines? AB and DC. According to the theorem, if the two parallelograms on same base and in between same pair of parallel lines, the areas of the two parallelograms are equal. So therefore, we can say that area of ABQD parallelogram is same as area of ABCP according to the theorem. Now we look at the third part of the same question. Prove that SPC triangle is this is congruent to RDQ. SPC triangle. Whereas SPC triangle, this one is congruent to RDQ. So we'll look at the triangles and see. We'll first take RDQ triangle. When you take RDQ triangle, what can you say about this angle? This angle and this angle. Both are equal because this line is parallel to this line. So, corresponding angles are equal. We can write RDQ angle is same as SPC angle because corresponding. angles. Then this angle, this one, y. If this is y, you are getting same angle here. We can write RQD angle is equal to SCP angle because those are corresponding angles. Now we know when you look at these two triangles, this length is equal to this length because this is a parallelogram. ABQD is a parallelogram. Opposite sides are equal. And this length is equal to this length as well because ABCP also a parallelogram. This is also equal to this. So what can you say about these lengths? DQ is same as PC. So we can write DQ is same as PC. Why? What's the reason? AB is same as DQ. AB is same as PC. So DQ is equal to PC. So we know two angles and one length equal. We can say RDQ triangle is congruent to, what's the other triangle? SPC triangle. What's the situation? Angle, angle, side. Now, we know that these two are congruent. What can you say about the area? Area of these two triangles are equal. Now, the fourth part says, prove that the area of parallelogram AXQR. AXQR. This parallelogram is equal to BXPS. BXPS is this one. How can we show that? Look at carefully. I'll color this also. We know from the first part, these two triangles are equal in area. And also from the second part, we showed that these two areas are equal. So what we can write down? First thing we can write from the previous step, ABQD parallelogram area is equal to the other parallelogram, ABCP parallelogram. So we did that in part, we can check it, we did that in part 1. Part 1 completed. And then from part 2, if these two triangles are congruent, we can say RDQ area is same as PCS area. That's from the second part. And also, if you take this one, remove from the parallelogram, what can you say? I'm taking 1 and 2, remove from that 1 minus 2. When I subtract these two, I get from this one, if I subtract this one, I get ABQR trapezium is equal to, when I remove this part from this parallelogram, I get ABSP trapezium. Now again I want to remove this area from both these sides. ABX triangle. ABX triangle area I want to remove from both sides. So when I remove from both sides, what I get? This trapezium, and when you subtract this area, I am getting AXQR. AXQR parallelogram. So that should be equal to. On the other side, when I remove ABX triangle, I am getting the other parallelogram. That's BXPS. BXPS parallelogram. So both are equal. We'll take exercise 8.2. First question. The figure shows two parallelograms that lie between the pair of parallel lines PU and SR. PU and SR. The area of the parallelogram PQRS is 40. With reasons, write down the area of the parallelogram TURS. It's given PQRS area is equal to 40 square centimeters. PQRS. So that's this parallelogram. You are asked to find out the area of TURS. TURS is this parallelogram. What can you say about these two? These two are on the same base and between same parallel lines. According to the theorem, those two areas are equal. So we can say PQRS parallelogram and TURS parallelogram, both on same SR base and in between same pair of parallel lines. Same pair of parallel lines, PU and SR. Then we know the areas are equal according to theorem. So this area is equal to TURS parallelogram. We know that PQRS is 40. So what's the area of TURS parallelogram? That's also 40 square centimeters. Question number 2. A rectangle ABCD and parallelogram CDEF are given in the figure. If AD is 7, this length is given 7 centimeters, and CD is given 9 centimeters. With reasons, write down the area of the parallelogram CDEF. CDEF. This area we need. Here, what can we say about this area? This is a parallelogram with same base. And what's the height of the parallelogram? We see that height of the parallelogram is same as AD, 7 centimeters. So what's the area of the CDEF parallelogram? I can write base times the perpendicular height. 9 times 7, 63 square centimeters. Question number 2. A rectangle ABCD and parallelogram CDEF are given in the figure. If AD is 7, this is 7 and CD is 9, with reasons, write down the area of parallelogram CDEF. Now here you have given two parallelograms on the same base and in between same pair of parallel lines. What can you say about the areas? Areas are equal. So we can say ABCD rectangle and what's the other one? CDEF parallelogram, both on same base CD and between same pair of parallel lines. Same pair of parallel lines, CD and FA. According to theorem, ABCD rectangle area is equal to CDEF parallelogram. But we know area of the rectangle is length into width or breadth into length. 9 times 7. So what's the area of the CDEF parallelogram? That's also equal. So that's 63 squared centimeters. Question number 3. The figure shows two parallelograms ABCD and PQRS that lie between the parallel lines AQ and DR. It is given that DS, this length DS is equal to CR. Show that DC is equal to SR. How can we show that? According to the diagram, we know DS is equal to CR. This is given. I want to add SC to both sides. SC. What happens? DS plus SC becomes DC. SC plus CR becomes SR. So straight away we get DC equals SR. That's the first part. And this is given as well. Now we'll look at the second part. Prove that the area of the pentagon ABXSD. ABXSD is this area. ABXSD pentagon is equal to the area of the pentagon PQR CX. This pentagon. You are asked to show that. From the previous part, we know that this length is equal to this length. Now we'll try to do that. If this length is equal to this length, we know if this and this equal, this is also equal to this one. Why? This is a parallelogram. I can say AB is equal to DC. But we know that DC is equal to SR. So this length is same as this length. So we can write SR is equal to PQ, and all these lengths are equal because of that. Because that's a parallelogram, and from the first part we proved that DC is equal to SR. So all these sides are equal. That means these two triangles have the same area. Why? You get different bases but equal bases. Two triangles, we can write ABCD parallelogram area is same as SRQP parallelogram area. Why? Equal bases and in between same pair of parallel lines. That's the reason. So the area of the two parallelograms are equal. Now we'll try to subtract the small area from both of these parallelograms. What happens when you subtract XSC triangle from both sides? What you get? When you subtract the area, you get this pentagon. I'll show that with this color. When you subtract this area from this, I'm getting this one. Other side, when you subtract this small triangle from this, you get this side. So these two should be equal. I can write therefore, when you subtract this one, you get ABXSD pentagon area is equal to the other area. What's the other pentagon? PQRCX pentagon. Now we'll take the third part. Same question, third part. We found these two areas are equal. Now the third part, prove that the area of the trapezium APSD, this one is equal to the area of the trapezium BQRC. This one. From the previous part, we found that this area is equal to this area. Now, what we can do? There's an extra triangle. We can add that extra triangle to both sides. So we can prove that using the previous part. A, B, C, A, B, X, C, D, pentagon is equal to PQR CX pentagon from the previous part. Part 2. I'm adding this area both sides. BPX. BPX triangle I'm adding to both sides. BPX triangle. So what I get? When I add this part plus this part, I get the trapezium. The trapezium is APSD. Trapezium should be equal to, then what's the other side? When you add this with this triangle, you are getting the other trapezium. BQRC trapezium. Question number 4. Based on the information in the figure, name two parallelograms which are equal in area to the area of the parallelogram PQRS. Where's PQRS? Here, this is the parallelogram given. So you are asked to write down two parallelograms. So that should be on the same base and in between same pair of parallel lines. Here we can see this is same as this one. So what's the other parallelogram? PQAB parallelogram should be equal with PQRS. Now we'll look at this base. When you look at this base, this area also equal. So I can write this is same as PSCE parallelogram. So here I can write this PQRS parallelogram is same as PQAB parallelogram, and also PQRS parallelogram is equal to PSCE parallelogram. Now we look at the second one. Name two parallelograms which are equal to the area of the parallelogram ADCR. ADCR, this one. I'll take another color. ADCR, this one now. So ADCR area is same as what? We get this base with this parallelogram. So CDBS parallelogram. And also if I take this base, AD as the base, I can get this as well. So this is again ADCR parallelogram is same as AD, this one, QADE. Then third one, prove that the area of the parallelogram PECS is equal to the area of the parallelogram QADE. From this, what we can say? This is equal to this. This is also equal to this. So that means we can see this is equal to this one. QAD is equal to CDBS. And this is equal to this one. So from the first part we can say PSCE parallelogram is equal to PQAB parallelogram. And from this one we can say QADE parallelogram is same as CDBS. What can you say about these two? PQAB. Where's PQAB? PQAB is this one. and where CDBS, CDBS, this one. We have to show that these two are equal. What can we say about that? We know these two are equal. Now when you look at these two parallelograms, QADE, QADE is same as what? QADE is same as PQAB. This is same as PQAB. What's the reason? Same base. What's the base? QA is the same base. And both are in the same, both are in between same parallel lines. And here I can write, I'll take it here, and also with this side, this is about QA, this triangle. PECS, when you take PECS parallelogram, PSCE or PECS, this is same as this one. Why? SC is the same base and in between same parallel lines. So we can write S, this is equal to SB, CD. That means the other triangle, this one, what's the common base? Common base is SBCD, SBCD. This is the base. SBCD and PESC. So this one, SC is the common base, same base. Now, when you compare these two, what can you say? So this is the same parallelogram. Because of that, you can say this is equal to this one. So PECS parallelogram area is same as the other one. Other one is QADE. Question number 5. Based on the information in the figure, prove that the area of triangle ADP, this triangle, is equal to the area of the triangle BRC, this one. Okay, so we'll try to prove that. We know ABRP parallelogram is equal to, area of this parallelogram is equal to ABCD parallelogram. What's the reason? Same base AB and in between, lies in between, same pair of parallel lines. Same pair of parallel lines. AB and DR. The areas are equal. Now look at this one. We are trying to subtract APC. We are trying to subtract APCB trapezium from that. I'm subtracting APCB trapezium from both sides. What happens when you subtract big area minus this one? You get ADP triangle. Here this one side you get ADP triangle. What about the other side? When you take this rectangle, subtract this one, you get CBR triangle. So the areas are equal. Question number 6. Construct the parallelogram ABCD such that AB is 6, DAB is 60 and AD 5 centimeters. So you are asked to construct. So here you have done this in grade 10 class. So we'll try to sketch the diagram. ABCD is a parallelogram. So here first I can draw AB line and then I can mark A as any point. Then how can I construct? I can take 6 centimeter length from the compass and keep it here and draw an arc. So this is 6 centimeter. So that point I can mark as B. Then the angle DAB is 60 degrees. DAB. So this angle is 60. How can we construct using the compass? You can take certain distance, keep the compass on point A, draw an arc here and also a big arc like this. Then according to the property of equilateral triangle, all angles 60 degrees. So you have to take the same length and keep it here and draw an arc. So here when you take a length, certain length, you have to take the same length here. And then what we do, we can connect these two lines. So that's the 60 degree angle. That's DAB. So the D point should be on this line. And what's the other information given? AD length is 5 centimeters. So you have to take the ruler and the compass, measure 5 centimeter length and you can mark here. So keep the compass on point A and mark here. That's 5 centimeters. So this point becomes point D. So that's the ABD points. Now we need to construct ABCD parallelogram. ABCD. Now that means we need to construct a parallel line to this one. How can we draw a parallel line? We can use again compass and draw the parallel line. We can use the property of alternate angles. Alternate angles are equal. So what I can do, I can measure here to here, this angle, this length. I can keep the compass here, measure this length and from here also I measure the same angle. So here I can mark here as well as here. So I can draw a big line like that. Then again I can keep the same length and mark here. Because if this is 60, the other side also 60. I'll again explain. If this is 60 according to the parallel lines, what's the property? If this is 60, this is also 60 degrees. Alternate angles are equal. So I want to draw a 60 degree angle here. So take any length here, draw an arc, big arc like this and also keep it here and draw a another arc. Then you can connect the 2 points. So here I can connect this point with this one and draw the parallel line. So this is also 60 degrees. Then if it's a parallelogram, opposite sides are equal. So if this AB is 6 centimeters, DC also 6 centimeters. Again, take the compass, keep the distance here and mark here 6 centimeters. And that point becomes the C point. And then connect all the points. So I can connect this point and complete the parallelogram. Then what's the next step? Construct the rhombus ABEF equal in area to the area ABCD and lying on the same side of AB as the parallelogram. State the theorem that you used for your construction. Now the areas are equal. So that means the two shapes, the parallelogram and the rhombus, should be on the same base and in between the two parallel lines. So we use that property. According to the theorem, we can say you need to draw the ABC, which rhombus? ABEF. If it's a rhombus, the length should be the same. All sides are equal in rhombus. It's a parallelogram, but all sides are equal. Now we know ABEF is a rhombus. Now all sides are equal and one side is given 6 centimeters. So what we can do, we can take 6 centimeter length and keep the compass here and mark an arc so that it will cut the DC line. So when you take the arc, here you get the point. Which point? ABEF, the point E. That means this length is 6 centimeters. And we need to do the same thing for F point. Either you can take 6 centimeters from this side and mark the arc. That's easier to do, and that's the F point. So we can draw the rhombus is ABEF. All sides are equal, and ABCD is the parallelogram. So what's the theorem we used? We used the property that same base AB and in between AB and DE parallel lines, the areas are equal. ABC D parallelogram area is same as ABEF rhombus. That's the theorem we use to construct this diagram. Example 1 in your textbook. It says the figure illustrates a parallelogram PQRS. PQR is the parallelogram and a triangle STR on the same base and between the same pair of parallel lines. The area of the parallelogram is 60. So this area is given 60 square centimeters. What's the first part? Find the area of the triangle STR. STR, give reasons for your answer. We can see that this STR and this one, the parallelogram, on the same base SR and in between the same pair of parallel lines. Write down STR triangle and PQRS parallelogram on same base SR and between the two parallel lines SR and PQ. So according to the theorem, we can say that the STR triangle area is half the area of the parallelogram. But we know the parallelogram area is 60. So what's the area of the triangle? Half times 60. So you get 30 square centimeters for the area of the triangle. The second part, if ST is 6, ST is 6. This length is given 6 centimeters. Find the length of the perpendicular RX from R to ST. You are asked to find out RX length. But we know the area of the triangle is 30. We can use that property. We'll use that one. 30 centimeters squared is equal to half times, if you take base as 6 centimeters, what's the perpendicular height? Rx. Then when you simplify, what you get? 2 and 6, you get 3. 3 Rx is 30. So what is Rx length? Divide by 3. 10 centimeters. Example number 2. E is a point on the side DC, this one, of the parallelogram ABCD. The straight line drawn through B parallel to AE, this one, meets DC at point F. AE produced and BC produced meet G. Prove that ABFE is a parallelogram. So the first part, ABFE. ABFE is a parallelogram. What can you say ABFE? We know that AB is parallel to DF. It's given. And also AE parallel to BF. That's also given. Opposite sides are parallel. So opposite sides are parallel means this is a parallelogram. So therefore ABFE is a parallelogram. Second part. The areas of the parallelograms ABCD and ABFE are equal. ABCD, that means this one, and ABFE. What can you say about these two? Both are equal. What's the reason? We can straight away write down ABCD parallelogram. Area is same as ABFE because both on same base AB, and in between two parallel lines, same pair of parallel lines AB and D, write it again, DF. So according to theorem, if this happens both on same bases and base and in between same pair of parallel lines, the areas are equal. Then the third part, the area of triangle ACD. ACD, this triangle. I'll take another color. Now we need to check this triangle and BFG. BFG triangle, this one. We have to show these are equal. How can we do that? We can say ADC, this is the ADC triangle is same as ACB triangle. These two are equal. Why? AC is the diagonal and diagonal bisects the parallelogram equally. Diagonal AC bisects equally. Then what's the next part? And also we can say when you take this base, what's that base? BF base. When you take BF base and these two, in between these two lines, this area is same as which one? Is the half of this parallelogram, because the triangle and the parallelogram in between the same pair of parallel lines. So I can say about this triangle BFG. BFG triangle is exactly half of this parallelogram ABFE. What's the reason? Same base BF and in between same pair of parallel lines. And also from this, what can you say about ADC triangle or ACD triangle? I can say ACD triangle is half of, this one is half of ABCD parallelogram. Half of ABCD parallelogram. What's the reason? Again, same as before. Here we'll look at the diagram. This is bisects equally, and if you take this area, this and this add up to the parallelogram area. So if you take one triangle, that's half of it. Then by looking at these two, we know this is equal to this one from previous part. So when right hand side is equal, what happens to the left hand side? From 1 and 2, 1 equal to 2. These two sides are equal. Then straight away we can say BFG triangle area is same as ACD triangle. Now we'll look at exercise 8.3 in your textbook. First question, the area of the parallelogram ABCD in the figure is 50 square centimeters. ABCD, this parallelogram. You are asked to find out the area of triangle PDC. PDC is in between the same pair of parallel lines and on the same base CD. What can you say? Straight away you can write PDC area is half the area of ABCD parallelogram. Why? What's the reason? Same base CD and between same pair of parallel lines CD and AQ. But we know the area of the parallelogram is 50. So what's the half of 50? You get 25 square centimeters for the area of the triangle. Second part, what is the area of triangle DCQ? DCQ is this one. So this one is also half of the triangle, half of the area of the parallelogram, because same base and in between the same pair of parallel lines. So what can you say about DCQ triangle is also 25 square centimeters because same base CD and in between CD and AQ parallel lines. Question number 2. The point P lies on the side DC. This one. And it's a parallelogram ABCD. The straight line drawn through B parallel to AP meets DC produced at Q. AP produced and BC produced meet at R. Prove that the area of triangle ADR, we'll mark that one, ADR triangle is equal to the area of triangle BQR, this triangle. When you look at these two triangles, what can you say about this rectangle and this triangle? We can say straight away ADR triangle is half of ABCD parallelogram. What's the reason? Because on the same base AD and in between same pair of parallel lines AD and BR. So that's half of that. And also we can say, when you look at the other side, this rectangle, this parallelogram and this triangle, what can you say? Half of that. We can write BQR triangle is half of ABPQ parallelogram. What's the reason? On same base BQ, this is the common base, and in between two pair of parallel lines, that AR and BQ. Now, what can you say about these two parallelograms? ABCD parallelogram, ABCD parallelogram and ABPQ parallelogram, both are equal. What's the reason there? AB is the common base on same base AB, and in between the parallel lines AB and DQ. Now what can you say? These two are equal and multiply by half. Because of this, we can straight away write down ADR triangle is same as BQR triangle. That's what you have to prove. Question number 3. In the figure, SQ has been drawn parallel to side AB. This one. And you have given ABCD such that it meets the side AD at S and side BC at Q. Prove that the area of quadrilateral PQRS. Where's PQRS? PQRS. This quadrilateral is exactly half the area of the parallelogram ABCD. ABCD. So you have to show that. If you take the big parallelogram, this area is half of that. So you need to show that PQRS quadrilateral area is exactly half of ABCD parallelogram. This is a quadrilateral. So how can we start that? Now look at carefully. We can see that this rectangle and this triangle, both on same base SQ and in between two parallel lines SQ and AB. So what can you say about the area? The area of the triangle is half of this parallelogram. So I can write straight away PQS triangle area is equal to half of ABQS rectangle. What's the reason? This is on same base SQ and in between AB and SQ. And what can I say about this one? When you look at the other side of the triangle, this part, what can you say about this parallelogram and this triangle? We can say SQR triangle is half of SQCD parallelogram. What's the reason? On same base SQ and between SQ and CD parallel line. Now I want to add these two. This is first one and this is second one. I'm adding 1 and 2. What you get? PQS triangle plus SQR triangle is equal to half of ABQS plus half of SQCD. When you add these two, what you get? I'm adding these two triangles. I'm getting this quadrilateral. Left hand side, I'm getting PQRS quadrilateral. What about the other side? When you add this parallelogram and this parallelogram, you get the big parallelogram. I can write this is half and half. I can take it out, and ABQS plus SQSD, I can write ABCD parallelogram. So what's the final results? We found that PQRS quadrilateral is equal to half of ABCD parallelogram. Question number 4. P is any point on the side AB of the parallelogram ABCD. Prove that area of APD, this area, and BPC area, this one, when you add, you get area of DPC. So when you add these two, you have to show that this is equal to the other area. When you look at the diagram, I can write down DPC area is half of ABCD parallelogram. What's the reason? Reason is on same base CD and in between AB and CD parallel lines. That's half of ABCD. And when you look at the diagram, if I add all these triangles here instead of ABCD, what can I write? Half of, without writing ABCD parallelogram, I can write APD triangle plus DPC triangle plus PBC triangle instead of ABCD. Then I want to multiply the whole thing by 2. When I multiply whole thing by 2, I am getting 2 DPC triangle is equal to APD triangle plus DPC triangle plus PBC triangle. Now I have same terms here. I want to take this one to this side. When I take this one to this side, I can subtract 1. 2 DPC minus DPC, I am getting 1 DPC triangle. That's equal to APD triangle plus PBC triangle. That's what we need to find. DPC triangle is APD triangle area plus BPC or PBC. Question number 5. In the figure, the point P lies on the side AD, this side, and the parallelogram APCD, and the point Q lies on AB produced. Prove that area of CPB, this area is equal to area of CQD. CQD is this one. How can we find out? We need to find out these areas are equal. We'll take CPB triangle. CPB triangle. We can see that this is half of ABCD parallelogram. What's the reason? When you take BC as the same base, and in between parallel lines BC and AD. What about the other triangle? CQD triangle. Look at that one. I'll take another color. CQD. This one. This one is again half of ABCD. What's the reason? Now the base is CD. This and this. Same CD base, and between the two parallel lines CD and AQ. What can you say about these two? The right hand side is equal. So according to 1 and 2, 1 and 2 are equal. So therefore, triangle CPB area is same as triangle CQD. Question number 6. It's given AB parallel to DC. Already marked there. And DC is greater than AB. DC is greater than, the length is bigger than that. And it's a trapezium. The point E lies on the side CD such that AB and CE equal. AB and CE. This length is equal to this length. It's already given. And it says DE such that the area of triangle AFE is equal to area of triangle ADF. AFE, triangle area is equal to ADF. That's already given. Prove that the area of trapezium ABFD, this trapezium ABFD, this trapezium is equal to half of the area of the trapezium ABCD. Half of this bigger one. Now what we need to prove? We need to prove that a trapezium ABFD is equal to half of the trapezium ABCD. Now look at the diagram. The given information is these two areas are equal. ADF triangle and AFE triangle both are equal. So if you take ADE triangle, What can you say about this one? We can say that's half of ADE triangle is double of ADF, or we can say other way around. I can write this is double of ADF because these two are equal. Or in other words, I can write ADF triangle is what? ADF triangle is half of ADE triangle. Because it's given. What's the reason? AFE triangle is same as ADF triangle. That's the first part. What is ABF triangle? ABF triangle. When we take ABF triangle, I can say this is half of ABCE parallelogram. Why? Because on the same base, AB, and in between the two parallel lines AB and CD. I want to add these two. What happens when I add ADF and ABF? I'll write 1 and 2. This is addition of 1 and 2. This becomes half. Half is common. Take it out and I can write ADE triangle plus ABCE parallelogram. Now when you add these two, what you get? ADF. ADF is this. And ABF. ABF is this. What you get? I'm getting ABFD trapezium. This is ABFD trapezium. This is trapezium. That's equal to half of. When I add ADE, I'll take another color. ADE, this triangle, and ABCE parallelogram. This whole thing. What's the total thing? I'm getting the whole trapezium. So I can write instead of that, this is half of ABCD trapezium. So finally we got ABFD trapezium is equal to half of ABCD parallelogram. Question number 7. O is the midpoint of the side BC of the parallelogram. AB, CD and X an arbitrary point on AB. Also XO produced and DC produced meet at Y. Prove that the area of BOX this one is equal to the area of COY. Asked to show these two. What's the rule? We have given these two lines are parallel and these two lines are parallel. Now the first part we need to find out area of BOX is equal to area of COY. Now look at these two triangles. When you look at these two triangles, BOX triangle and OCY triangle, we know that BO is equal to OC. It's given in the diagram. And also, what can you say about this angle and this angle? Both are equal. XBO angle is same as OCY angle because those are alternate angles. Other side, this angle is same as this angle. That's also alternate angles. BXO angle is same as OYC angle, alternate angle. So what can you say about these two triangles? These two are congruent. What's the situation? It's angle side. If the two triangles are congruent, that means same size and same shape. So therefore, area of BOX is same as area of OCY or COY. We'll take the second part of the same question. The area of trapezium AXYD, AXYD, this one, is equal to the area of parallelogram ABCD. ABCD. Now when you take this part, what can you say about this part? This is a 2, 3, 4. How many sides are there? 1, 2, 3, 4, 5. It's a pentagon. We'll take the pentagon AXO CD pentagon. Area is same as AXO CD pentagon. That's the same thing. What I'm trying to do, I want to add these two triangles. We found in the first part, the areas are equal. I am trying to add OBX triangle and OCY triangle. This is second one. This is done before. Now when I add these two, what happens? AXOCD pentagon. When I add the others, OBX triangle, what am I getting? This one with OBX, I get the ABCD parallelogram. What about the other side? This one, and when I add this triangle, I am getting AXYD trapezium. So the other side I am getting AXYD trapezium. So the areas are equal. I just added the two equations. So that's part 2. Part 3. Part 3 says the area of trapezium AXYD is twice the area of triangle ADO. ADO. This one. But we know when you take ADO triangle, that's equal to half of the parallelogram area, half of parallelogram area, A, B, C, D parallelogram. What's the reason? Same base AD and in between AD and BC parallel lines. That's ADO. And we know this one is same as the, instead of this one, that's same as ABCD. We did that before. ABCD parallelogram is same as AXYD trapezium. So what's the final thing? Area of the triangle is half of this. When you take the other way around, we can write AXYD trapezium is twice, multiply both sides by 2, twice of ADO triangle. So that's what it says. The area of trapezium AXYD is twice the area of triangle ADO. Example 1 in your textbook. In the given figure, AB is parallel to CD. Name a triangle that has the same area as triangle ACD. ACD, this one. Write down the theorem that your answer is based on. So what's the first part? ACD. ACD is same as which one? BCD. So BCD triangle area is same as ACD triangle. What's the reason? Both triangles on same base CD and between two parallel lines AB and CD. That's the reason. And second part, if the area of triangle ABC is 30, find the area of ABD. Now we need to look at the other triangle, ABC and ABD. These two also equal. We can say ABC triangle area is same as ABD triangle area because on same base AB and in between two parallel lines AB and CD. So these two are equal. So if ABC is 30, so what is ABD? ABD also same as that. So 30 centimeter squared is the area of ABD triangle. Third one, prove that the area of triangle AOC is equal to BOD. So you are asked to show this is equal to this. We know that this triangle BCD, look at BCD triangle, is same as ACD, and also, so this is from the first part. I'll write A, B, C, D we did in the first part. And I want to subtract OCD triangle from both sides. What happens? When I subtract BCD and OCD part, I am getting BOD triangle. This is area. All these are areas. Then when I subtract OCD from ACD, I am getting AOC. So both are equal in area. Example 2. The point P lies on the side BC of the quadrilateral ABCD. The line drawn through P parallel to AP meets the line drawn through C parallel to DP at X. Prove that the area of triangle ADX is equal to ADX, this one, this one is equal to the area of the quadrilateral ABCD, is this one. Okay, so now we'll consider ABCD quadrilateral. When you take that quadrilateral, I can take these three triangles, and when I add these three triangles, I get the quadrilateral. So I'm focusing on this. I'm first taking ABP triangle. ABP triangle and this one, what can I say? This triangle, ABP triangle. This one, I'll take another color. When you take ABP triangle, try to find out another equal triangle. Here, if you take AP base, what's the other triangle? APX triangle. We can say that AP same base and in between AB and in between these two, AP and BX. AP and BX, two parallel lines. Now we look at ADP triangle. When you take ADP triangle, that's equal to, try to find out another triangle there. We can't find, so I'm writing ADP is equal to ADP. Then I want this triangle, PDC. PDC is equal to which triangle? DPX. Why? Now, if you take this as the same base, DP same base, and in between DP and CX parallel lines, those two triangle areas are equal. I want to add all these three equations. 1 plus 2 plus 3. AB, AP triangle plus ADP triangle plus PDC is equal to, other side is APX plus ADP DPX. I can see when I add this one, this one, this one, I get ABCD quadrilateral and when I add APX, I'll color those APX, ADP, and DPX. I am getting AXD or ADX triangle. So that's equal. Exercise 8.4 in your textbook. First question, the area of triangle ABP, which lies between the parallel lines AB and CD, and it says it's 25. APB, this triangle is given 25 square centimeters and you are asked to find out the area of ABC. What can you say about the area? Same. ABC area is same as this. What's the reason? Same base. Both are on same base. On base AB and between the two parallel lines AB and PC. Second part, if the area of triangle ABX, this part is 10 now. What is the area of triangle ACX? This part. We know that ABC area is 25. So how can you get ACX area? ACX area is ABC area minus ABX area. When you subtract from 25, you get the answer. So we know ABC is 25 square centimeters, ABX given as 10. When you subtract, you get 15 square centimeters for the area of ACX. Third part, explain with reasons what's the relationship between the areas of the triangle ACX and BPX. We'll try to find out. ACX, this one, and BPX. BPX is this one. What's the relationship? From the previous part, we found that these two triangle areas are equal according to the theorem. When you subtract 10 from that, we got this is 15 and here also we are getting 15. So what can you say about the other part? We can say this is equal. I'll do this one. We found ABC triangle is equal to ABP triangle before. And then subtract 10 from both sides. That means ABX triangle area, we can get ACX triangle is same as BXP triangle. So both areas are equal to, we can say, if we want the value, that's equal to 15 square centimeters. Because from the subtraction. Question number 2. In the figure, DE drawn parallel to the side BC of the triangle ABC such that it touches the side AB at D and side AC at E. Name a triangle which is equal in area to the triangle BED. BED. What's the triangle equal? Look at carefully and see. This one. Because when you take these two parallel lines, we see that DEC area is equal to BED triangle. The reason is DE same base and both between the two parallel lines DE and BC. And the second part, prove that the triangles ABE is this one and ADC both are equal. So in second part we need to show that ABE triangle is equal to ADC triangle. But we know from the first part this area and this area equal. And I can add the extra triangle to both the sides. We found DEC triangle is equal to BED triangle from the previous part. I'm adding ADE triangle to both sides. Then what happens? When I add ADE triangle, I'm getting ABE triangle on this side. And what about the other side? BED plus ADE, I'm getting AB, this one. BED, BED and ADE, I'm getting ABE. This side here, both sides are other way around. Now, if I add DEC, this one and this, I'm getting ACD triangle. This one is ACD triangle. And if I add BED and ADC, I'm getting ABE triangle. So both are equal. Question number 3. The straight line drawn through the point B parallel to the diagonal AC of the quadrilateral ABCD meets the side DC produced at E. Name a triangle which is equal in area to the triangle ABC. Where's ABC? This one. We need to write down another triangle equal in area. So, what's the equal triangle to ABC? We can see that ACE triangle is equal to ABC triangle. What's the reason? Both are on same base AC and in between two parallel lines AC and BE. And second part, prove that the area of the quadrilateral ABCD is this one, is equal to triangle ADE. Now we found ACE triangle is equal to ABC triangle from part 1. I am adding ADC triangle to both sides. I am getting ACE triangle plus ADC. Here I am getting ABC triangle and ADC. What happens? ACE and ADC, I am getting ADE triangle. What about the other side? ABC and ADC, I am getting ABCD quadrilateral. So ABCD quadrilateral is equal to ADE triangle. Question number 4. ABCD is a parallelogram. It's already marked. A straight line drawn from A intersects the side DC at Y and BC produced at X. Prove that the triangles DYX and AYC both are equal. This triangle and what's the other triangle? DYX triangle and AYC. These two triangles are equal. Now look at carefully what we can see. We can see ADC triangle is equal to ADX triangle. What's the reason? Both are on the same base AD, and in between AD and BX parallel lines. And I want to subtract this part from both of the triangles. I am subtracting ADY triangle from both sides. What am I getting? ADC triangle minus ADY, ADX minus ADY. ADC minus this, I am getting AYC triangle. The other one, when I subtract ADX and ADY from that, I am getting DYX triangle. So both are equal. Then second part, the triangles BCY triangle is equal to DYX. Now I need to show this one, BYC, BCY, this one. This one is equal to DYX. This is same as this. From the previous part, we found these two are equal. Now look at carefully these two. When you take AYC triangle that's equal to BYC triangle. What's the reason? Both are on same base YC and between AB and DC parallel lines. Between AB and DC parallel lines. So these two are equal. Now look at carefully left hand side. These two are equal. Therefore, from 1 and 2, 1 equals 2. Therefore, dyx area is same as BYC area. Question number 5. The point Y lies on the side BC of the parallelogram ABCD. Here diagram is not given, so we have to sketch it. So there's a parallelogram ABCD. ABCD. The point Y lies on the side BC. The side AB produced and dy produced meet at X. So AB produced and dy. Here Y is somewhere there, so I'll draw these 2 points. Dy produced meet at X. Prove that the area of triangle AYX I need to connect this one. So AYX triangle is equal to the area of triangle BCX. This area. So this one and this one. When you take these 2 triangles, BXC, these 2 triangles, what can we see? I can see this part is common to both the triangles. So we'll try to use that property. So when you look at the triangles, I can write down this area. Now we'll connect these 2 lines, BD. Now you have to prove that. We'll first write down that, prove that AYX triangle is equal to BCX triangle. We'll take this one. We'll take BDX triangle and BCX triangle. What can you say about those 2 triangles? Those are equal. BDX and BCX triangles are equal in area because both are on the same base BX and in between parallel lines DC and AX. Now I want to subtract BYX triangle from both sides. What am I getting? This triangle BDX minus this, I am getting BDY. Other side, BCX triangle minus BYX, I am getting CYX. Now look at, so we found these 2 areas are equal. Now, when you look at BDY triangle, I can write that's equal to BAY triangle. BAY triangle. What's the reason? Here same base and in between the two parallel lines. I can write this is equal to this because on same base BY and in between AD and CB parallel lines. From these two we can say CYX triangle is equal to BAY triangle because these two are equal. Now we'll try to add BYX triangle to both sides. So what am I getting? I am getting CYX plus BYX. I am getting BCX triangle. BAY and BYX, I am getting AYX triangle. So these two triangles are equal in area. Question number 6. BC is a fixed straight line segment of length 8. With the aid of a sketch, describe the locus of the point A such that the area of triangle ABC is 40. So we'll try to sketch the diagram. BC is a fixed straight line. BC is a fixed straight line segment with 8 centimeters. So this is fixed with 8 centimeter long. And the area of the triangle ABC is 40. So the area is the same. So you are asked to find out what's the locus of the point A. Now when you take the area of triangle, we know that area of triangles are equal when the triangles are in between same parallel lines and on same base. So if you take same base and if we take any parallel line to this, we can find out the any point A. Now we'll take A is on any parallel line to this one. To get area 40, what should be the perpendicular height? So we need to find out what is the perpendicular height of this. Area of ABC is 40 square centimeters. But we know area is equal to half times base times height. Half into base times height. That's equal to 40. So what should be the height? 2 times 4. 4h is 40. H is 10 centimeter. That means to get the area ABC 40, A point should be away 10 centimeters away from the line BC. So this should be 10 centimeter away from that. But according to the theorem, we know that when you take any point on this straight line, you get same area. So this can be one point, this can be another point, and this can be another A point. And all areas are equal to 40 square centimeters. So what's the path? Path of point A, or in other words we say locus of the point A. So locus of point A should be is 10 centimeter away from BC and it's a parallel line. So locus of the point A is a parallel line ten centimeters away from BC line. So you can take any point on this line as A to get the area 40 square centimeters. Question number 7. Construct the triangle ABC such that AB is 8, AC is 7 and BC is 4. We'll try to construct. So when you are constructing, you need to take only the ruler and the compass. AB is 8. So what we do? We mark point A, take the compass with length 8 and we can keep the point on A and draw an arc. That's the B point. It's 8 centimeters. Then AC is 7. AC is 7 means again take 7 centimeter long distance from the compass, keep on top of A and draw an arc. That's 7 centimeters. And BC is 4. Then what you do? You take 4 centimeter length, keep on top of B and draw an arc. Then we get the ABC triangle. So this should be C point. AC is 7 centimeters and BC is 4 centimeters. That's how we construct the triangle from the compass and the ruler. Then construct the triangle PAB, which is equal in area to the triangle ABC, with P lying on the same side of AB as C. PA is equal to PB. Okay, so here, according to the property, when there are two parallel lines and area of two triangles in between parallel lines are equal, we'll use that property. Construct the triangle PAB such that equal to ABC. Now we need to draw a parallel line to AB. How can we draw a parallel line? We can use the property of alternate angles and think about that. Here we can measure this angle. Here draw an arc and that same length you are drawing an arc here, and take the compass and measure this distance, and here you have to measure that distance, same distance here. That's how you measure an angle. Then after you get the point, you draw the line. That's the parallel line to this along C point. Now P point should be on this parallel line because the area of ABC triangle is equal to the area of PAB. Same base is AB. And also it's given PA is equal to PB. That means the P point should be in between A and B. That means we have to draw the perpendicular bisector. So we'll take AB point and try to draw a perpendicular bisector. Take any length and draw an arc here, an arc here. Again take the same length, keep the compass here, draw an arc here, arc here. When you connect those two, you get the perpendicular bisector. So this is the perpendicular bisector to AB. So that means this distance is equal to this distance. So P should be on the line, the parallel line passing through C. So definitely this point. So this is the P point. This should be the P point. And when you draw the triangle PAB, PAB is this triangle. We can say this is equal in area to ABC, and with P lying on the same side of AB, as C. That means on this side, and PA is equal to PB. So what are the steps we have to follow? To get the same area, first we need to draw a parallel line to AB along C. Then we need to draw the perpendicular bisector to AB because PA is equal to PB given. And the bisector, the perpendicular bisector and the parallel line meets at P. Then connect PAB triangle. Miscellaneous exercise in your textbook. We'll look at the first question. The length of a side of the square ABCD is given 12 centimeters. The point P lies on the side BC such that BP is 5 centimeters. Find the length of dx. So you're asked to find out the length of dx. Before we find out dx, we need to find out the length AP. How can we find out AP length? We know this is 12, that means this is also 12. Look at ABP triangle, APB triangle. It's a right angle triangle. We can use Pythagoras theorem. AP squared is equal to 12 squared plus 5 squared, and when you take the square root, you can find out AP length. What's that? 12 squared is 144 plus 25, you get 169. Square root of 169 is 13 centimeters. So AP length is 13 centimeters. And we know that when you take this rectangle and the triangle, what's the area of ADP triangle? It's half of area of ABCD rectangle, because same base AD and the two diagrams in between two parallel lines AD and BC. But we know what's the area of the rectangle? 12 times 12. So what's the answer? 2 times 6, 6 times 12. 72 square centimeters for the area of ADP. How can we find out the area of ADP using dx length? Dx is the perpendicular height. So half times dx times AP. AP we found out, that's 13. That's equal to the area of the triangle, that's 72. Now try to find out dx. Dx is 2 times 72 divided by 13. This one is not divisible by 13. So what's the answer? We can simplify. 2 times 2, 4. 2 times 7, 14. Divide by 13. When you divide, you get 13 times 1, 13 times 1 and 1 remaining. 11 and 1 over 13 centimeters for the length dx. Question number 2. X is point on the side BC of the parallelogram ABCD. The side AB produced and DX produced meet at P. And the side DC produced and AX produced meet at Q. Prove that the area of triangle PXQ, this one, is exactly half of the area of the parallelogram ABCD. This one. So, what you need to prove? You need to prove PXQ triangle is equal to half of ABCD parallelogram. When you look at the diagram, we see these two parallel and these two lines are parallel. Now we look at APD triangle. When you look at APD triangle is same as which triangle? APQ triangle. What's the reason? Both lie on same base AP, and between the two parallel lines AP and DQ. I want to subtract APX from both sides. What happens? APD minus APX, I am getting ADX triangle. Other side, APQ minus APX triangle, I am getting PXQ triangle. But we know when you take this triangle, I can write AXD triangle or ADX triangle is half of ABCD parallelogram because it lies in between these two parallel lines and AD is the same base. Now look at these two. You can straight away write down left hand side is equal. I can write PXQ triangle is half of ABCD parallelogram. Question number 3. The diagonals of the parallelogram PQRS intersect at O. So we'll draw the parallelogram PQ. Now here, this is a parallelogram. We'll draw it. PQRS is a parallelogram. So we can draw the two parallel lines. And the diagonals intersect at O. So these are the two diagonals intersect at O. The point A lies on the side SR. The point A lies on the side SR. So this side point A is there. Find the ratio of the area. I'll put somewhere here. A. find the ratio of the area of the triangle POQ, this area, and to that of the triangle PAQ, this one. So we'll write down what you need to find out, the ratio between area between POQ and area between PAQ. That's what we need to find. When you look at the diagram, what can you say about POQ area? POQ area is 1/4 of PQRS parallelogram, because these two are diagonals and equal areas are there. 4 equal parts are there. So one is POQ triangle. So that's 1/4 of PQRS parallelogram. And what about PAQ? PAQ is same as, I can write PAQ is same as PSQ triangle, because same base PQ, and in between PQ and SR parallel lines. So these two are equal, and also we know that PSQ triangle is half of PQRS parallelogram. Why? Because this is the diagonal and equally divide into two parts. Now, instead of PAQ, I can write down half of PQRS parallelogram area. Now, when you divide, these two get cancelled out. What's the ratio? 1/4 multiplied by 2/1. Divide by half means multiply by 2/1. When you simplify, you get the ratio 1/2, 1 to 2. If you want the ratio between POQ to PAQ triangle, it's 1 to 2. Question number 4. ABCD and ABEF are two parallelograms unequal in area drawn on each side of AB. So we need to draw the diagram. So we'll take AB is this, ABCD. So here we can draw CD is a parallelogram now. ABCD is one parallelogram, and I can draw another parallelogram, something like this, but that's ABEF. Both are unequal in area, but we know this is parallel to this one parallel to this one. Prove that DCEF is a parallelogram. DCEF is a parallelogram. These two. We can say here, when you take DCEF quadrilateral, DC is parallel to EF. These two lines are parallel. And also this length, DC length, is equal to AB, and AB is equal to EF because opposite sides of a parallelogram are equal. Then what can you say about these two sides? Therefore, CD is same as FE. So, opposite sides are equal and parallel. And because of this, we can say this is a parallelogram. In this one, in this quadrilateral DCEF, we found that these two lengths are equal and opposite lengths are equal and parallel. If these are equal and parallel, definitely these should be parallel. Opposite side of DF should be parallel to EC. So you can only make parallel sides with equal lengths here. So that means opposite sides are parallel and also these two lengths are equal. That means DCEF is a parallelogram. So therefore DCEF is a parallelogram because opposite sides are parallel. Now we look at the second part. The area of the parallelogram DCEF is equal to the sum of the areas of parallelograms ABCD and ABEF. We'll take these 2 points as P and Q. Now when you look at the diagrams, we can see that this length is equal to this length and this is also equal to this length. When you look at this triangle, this diagram, this rectangle or a parallelogram, this part, we can write down DCQP. DCQP area of the parallelogram is same as DCBA. What's the reason? DC is the same base and both these parallelograms in between the two parallel lines DC and AQ. And also I can write about this diagram. PQ FE. PQ FE parallelogram is equal to which one? AB FE parallelogram. Because these two parallelograms are on the same FE base and in between the two parallel lines AQ and FE. Now I want to add these two. When I add 1 and 2, what you get? DCQP parallelogram plus PQFE parallelogram is equal to the other side, DCBA parallelogram plus ABFE. Now look at the diagram and see DCQP and PQFE. What you get? We get DCEF parallelogram. What's the other side? DCBA and ABEF. That's the sum of these two areas. So I can write this is DCBA or ABCD parallelogram plus ABFE parallelogram. So here that's what you need to prove. This is equal to the sum of the other two parallelograms. Question number 5. ABCD is a parallelogram. We'll try to sketch it because the diagram is not given. ABCD is a parallelogram. So I'll draw something like this. And these two lines are parallel, opposite lines are parallel. EF has been drawn parallel to BD. This is BD and EF has been drawn parallel to BD such that it intersects the sides AB at E and AD at F. So we need to draw a parallel line to this such that it cuts the AB at E and AD at this is F and this is E. So there's a line FE parallel to BD. Prove that the triangles BEC, I'll take another color, BEC. This triangle and DFC. DFC triangle. These two triangles are equal in area. Okay, so here we'll try to do that. You need to prove a FDC triangle. FDC triangle is equal to BEC triangle. Now when you look at this diagram, we can write BEC triangle is equal to, if you draw a line here, I can write this is equal to BDE triangle. So this area is equal to this area. And also I can write BED or BDE area is same as this one. I'll take another color. This one. So I'll write BDE triangle. This area is same as BED DF. So you have to give the reason for that. Why this one is equal to this? BDE. BDE is same as this one, BEC, because same base BE and in between same parallel lines. This is also equal, BDF, and this one is equal. Now what's the common base? BD is a common base. BD is the same base and between same parallel lines. So from these two, I can say BDE triangle is equal to BDF triangle. Now we need to prove that BEC triangle is equal to DFC. And also we know that if you take BDF triangle, that's equal to BFDC triangle. This is also equal to FDC triangle. What's the reason? If you take FDC, this one and this one, same base FD and in between same parallel lines, between same parallel lines. Now what can you say now? When you look at carefully, this one, FDC, BDF, this one is equal to this, these two, as well as this is equal to this. So all these are equal. In the first step, they ask to show that the triangle BEC is this one, is equal to FDC. So here straight away from this I can write this one BE. So therefore BEC triangle is equal to FDC triangle. Now we'll look at the second part of the same question. Now you're asked to find out the triangle AEC and AFC. AEC and AFC. These two triangles are equal in area. Now we'll connect AC line. I'll take another color. I want to connect AC line. Now we'll look at this triangle. What can you say about ADC triangle and ABC triangle? We can say ABC triangle is equal to ADC triangle. Why? This is a parallelogram and AC is the diagonal. So the diagonal bisect the parallelogram equally. So I can say these two are equal because half of parallelogram A, B, C, D. And from the previous part, we found that BEC is equal to DFC triangle. That's from part 1. Now we'll try to subtract these two. When you subtract ABC triangle with BEC, what you get? We are getting this triangle ACE or AEC triangle. Other side ADC, ADC, and subtract DFC. When you subtract that one, I am getting AFC triangle. So these two also are equal in area. In this unit, we covered all exercises and examples, and also remember the 6 theorems that we covered related to areas of parallelograms and areas of triangles on the same base and in between same parallel lines.